Okay, my name is Mr. Moddy. Moddy. Sometimes you can call me Moddy Physics. Some people call me Moddy Physics Commissioner, the man of physics. And I'm here with you guys to solve problems, nectar problems. And I'm going to start with the nectar of 2018. I'm going to start with the nectar of 2018. National Examination Council of Tanzania, 2018, paper 1. And I'm going to start with the question number 1. The paper says answer all questions in this section. This is section A. Each of the items 1 to 10, choose the correct answer among the given alternatives. And write this letter beside the item number in the answer booklet provided. Roman 1. The correct formula to find the elastic force constant K of a spring is, in answering this question, first of all, you are required to draw a table like this. Question number 1. You can draw a table like this. See, this is question number 1 here. This is Roman 1. Roman 2 is here. Roman 3 is here. Roman 4. Here you have Roman 5. Here you have Roman 6. Here you have Roman 7. You have number 8. Here you have number 9. And lastly, you have number 10. Let's start with the Roman 1. The correct formula to find the elastic force constant K of a spring is, we have multiple choice A, B, C, D to E. But we know that the elastic force constant is a factor of elasticity, and we know in elasticity, force F, which is tension, is directly proportional to extension. Therefore, you can say the force F is equal to constant times E. E is extension, and F is the force. The force is the tension. K in this equation represented the elastic force constant. When you make K subject of the formula, you divide by E both sides. And you can say the elastic force constant K will be force divided by E. This force here is tension. So you may write here tension. You divide by the E represent extension. So you may write here extension. The correct formula to find the elastic force constant K of a spring is obtained from Hooke's law. And Hooke's law says that force is equal to a constant times extension. Or you can say, provided the elastic limit is not exceeded, the extension of an elastic body is directly proportional to force, or you can say force is directly proportional to extension. If you divide by E both sides, K is going to be obtained from this relationship here. And therefore, K is tension divided by extension. As we can see over there, tension divided by extension is A. Our answer here is A. Tension divided by extension. Roman 2. The question says, why oil used as a lubricant? All liquids which can be used as a lubricants are those liquids which have a very high viscosity. Very high viscosity. So the reason is there, why oil is used as a lubricant, A says has low density. It's not true. Any liquid which can be used as a lubricant should have a high viscosity. The answer there should be B, is high viscous. B. Has a low density, or as it is inflammable. Characteristics of lubricant. Any lubricant should have high viscosity. Should have high viscosity. Density is not a factor for a lubricating fluid. Or inflammable is not a factor for lubricating fluid. The factor for a liquid to be a lubricant we are going to look on its viscosity. High viscous liquid is a good lubricant. Viscosity is the internal friction which exists between fluid layers in motion. Liquids having high viscosity flow slowly, and the liquids which have low viscosity flow faster. For example, if you compare oil and the water, all liquids which flow slowly have high viscosity, and all liquids which can flow faster have low viscosity. Oil is a liquid with a high viscosity. That's why it's used as a lubricant, and not water, because water has a low viscosity, can flow easily. Oil cannot flow easily. Another example is honey. If you allow water and the honey to flow, water will flow easily, and the honey will not flow easily. And the liquid which does not flow easily has a high viscosity. And the property of any lubricating oil should have high viscosity. Viscosity kwa Kiswahili ni force iliyokuwepo katika fluid, katika fluid ambayo inatembea. Ni internal force ya ndani. Roman 3. Which one is a characteristic of a plane mirror? Which one is a characteristic of a plane mirror? Let us discuss about the characteristics of a plane mirror. Characteristic number 1 of a plane mirror. Plane mirror produces an image which is of the same size as the object. Image produced by a plane mirror have the same size as the object. This is a characteristic number 1. Characteristic number 2 of image formed in a plane mirror. The image formed in a plane mirror is virtue. The image formed in a plane mirror is the same distance behind the mirror as the object is in front. If this is the mirror here, if you put an object in front of the mirror, the image will be formed behind the mirror the same distance. This distance here, if this distance here is equal to 2, this distance will also be equal to 2. This is an object, this is an image. So the image formed in a plane mirror is the same distance behind the mirror as the object is in front. Characteristic number 3, same distance behind the mirror as the object is in front. As the object is in front. This is a characteristic number 3. Characteristic number 4 of the image formed in a plane mirror, the image is lateral inverted. Lateral inverted. If you look at the mirror, your image will face you. The right hand side of you will appear on the left hand side. We can say that the image is lateral inverted. This is a characteristic number 4. Laterally inverted. Now, in these characteristics, what we can see there, part A says it forms an image which is real and opaque. That's not true. It forms an image which is larger than the object. That's not true. See, it forms an image which is real and lateral inverted is not true. It forms an image which has the same size as the object. In our characteristic here, the image formed in a plane mirror is of the same size as the object. It forms an image which has the same size as the object. It should be D. E says it forms an image which is smaller in size than the object. That's not true. So our answer will be D. It forms an image which has the same size as the object. So we write here D. Okay, we go to Roman 4. Which one is not a region of electromagnetic spectrum? First of all, we must know what is the electromagnetic spectrum. This is an arrangement of all electromagnetic waves in order of their wavelength or in order of their frequency. And I can show here, we can show here electromagnetic waves arrangement in order of their wavelength or in order of their frequency. And here I'm going to arrange all electromagnetic waves in order of increasing wavelength. Let's start here with the The first one is gamma radiation, gamma rays. So here we have gamma rays. We have X-rays. We have X-rays. Here we have ultraviolet radiation, UV radiation. UV radiation is here. And we are going to have visible light. The visible light starts with the violet color. Violet. Here we have indigo. We have blue. We have green. We have yellow. We have orange. And here we have red. Here we have 7 different colors of the white light. 1, 2, 3, 4, 5, 6, 7. 7 different colors of the white light. This is the visible light. Visible spectrum. This is the visible spectrum. Gamma rays, X-rays, ultraviolet radiation are invisible radiations. Now, from the visible spectrum, we are going to have infrared radiation. Here we have infrared radiation. And we have radio waves lastly here. We have radio waves. Radio waves. We have microwaves. We have radar waves, TV waves, and radio broadcasting. These are the electromagnetic waves. This is the visible radiation, visible spectrum. Visible spectrum. The question says, which one is not a region of electromagnetic spectrum? This is electromagnetic spectrum, arrangement of all electromagnetic waves in order of their wavelengths. As you go in this direction, you go in the direction of increasing wavelength. This is the direction of increasing wavelength. Part A says radio wave. Radio wave is one of the part of electromagnetic waves. B, X-ray. X-ray is electromagnetic wave. We have C, infrared light. Infrared light is infrared radiation here, is also a part of electromagnetic wave. Ultraviolet light, you have UV radiation here. This is also the region of electromagnetic spectrum. E, we have invisible light wave. Invisible light wave. Hatuna kitu kinaitwa invisible light wave. We have a visible spectrum. The visible spectrum is a visible light wave, which consists of 7 different colors of the white light: violet, indigo, blue, green, yellow, orange, and red. So our answer there should be E, invisible light waves. Invisible light waves is not a region of electromagnetic spectrum, because in the electromagnetic spectrum we have visible light waves. It is the visible part of the electromagnetic spectrum. Kwa hiyo, which one is not a region of electromagnetic spectrum is invisible light waves. E. We continue. Roman 5. What quantity of it is required to raise the temperature of 25 kilogram sample of mercury from 20 degrees centigrade to 30 degrees centigrade? Quantity of it required to rise the temperature of 25 kilogram sample. Here we have mass. The mass is 25 kilogram of mercury. The initial temperature is 20 degrees centigrade. 20 degrees centigrade. The final temperature is required to be 30 degrees centigrade. Now, in this problem, we must have the specific heat capacity of mercury. This will be given at the front page of the paper. Very bad. Specific heat capacity. Yeah, as you can see there at the front page of the paper, the specific heat capacity of mercury is 1395 joules per kilogram, degrees centigrade. Now, having these quantities, we can calculate the quantity of heat required. How can we get the quantity of heat here? A formula is going to be used to calculate the quantity of heat required. Now, because there is a change of temperature from theta 1, 20 degrees centigrade to theta 2, which is 30 degrees centigrade, the amount of heat involved here is sensible heat. Sensible heat. Sensible heat is the amount of heat in which the thermometer can show a change of temperature here. And therefore, the quantity of heat required will be given by mass of a substance. You multiply by specific capacity. You multiply by the change in temperature. In this case, the mass of a substance is 25 kilogram. 25 kilogram here. You multiply by the specific capacity, 1395 joules per kilogram degree centigrade. Then you multiply by the change of temperature. The change in temperature is from 20 degrees centigrade to 30, and therefore the change will be theta 2 minus theta 1. This will be 30 minus 20 degrees centigrade. Now you can calculate it from here. Have a calculator here. Here we have 25. You multiply by 1395. 1395. You multiply by 30 minus 20. Here we have 30 minus 20. We are going to have 348 and 750. Here we have 348, 750. Quantity of heat measured in joules. Now, in your multiple choice, we have some numbers there. Yeah, we have there. We have A, 1,743,000 and 750 there. In our multiple choice, we have B there, 348, 750. B is our answer. B. Okay, Roman 6. The question says, when a silicon element is doped with the phosphorus atoms, it produces A, we have a p-type semiconductor. B, we have a p-n junction diode. C, an intrinsic semiconductor. E, an n-type semiconductor. D, we have a bipolar semiconductor. This is the doping process. Doping is the process of adding impurity atoms to a pure semiconductor to produce an extrinsic semiconductor. In this case, the silicon element is doped with the phosphorus. Silicon doped with the phosphorus. Doped with the phosphorus. Silicon is a tetravalent element. Tetravalent element. When we say that silicon is a tetravalent element, it means that it has 4 electrons in the outermost shell of the atom. The outermost shell of the atom has 4 electrons, as you can see here. Phosphorus is a pentavalent element. This one is a pentavalent element. Has 5 electrons in the outermost shell of the atom. Now, when phosphorus is added to silicon, phosphorus acts as impurity to a silicon. Suppose this one here is the phosphorus. The phosphorus here as impurity atom has a valence of 5 in the outermost shell. So it is introduced in the silicon semiconductor. This one is silicon atom, and this one also is silicon atom. Silicon. Phosphorus is introduced in the silicon semiconductor. Phosphorus is a pentavalent element, has 5 electrons in the outermost shell of the atom. Na kwa kawaida hizi semiconductor materials huwa zinatengeneza covalent bond, a bond which is formed by sharing of electrons. In this case, phosphorus kwa sababu ana electroni 5 nje, atatoa elektroni yake ya kwanza, anafanya bondi na silicon huyo. Na silicon atatoa elektroni yake moja kufanya bondi na huyo. Alikuwa nazo 5, kashatoa moja nje. Bado 4. Anatoa elektroni yake moja anafanya bondi hapa, na huyo anatoa elektroni yake moja anafanya bondi hapa. Alikuwa nazo elektroni 5, tayari kashatoa moja hapa na kashatoa moja hapa. 2 zimetoka, bado 3. Phosphorus anatoa elektroni yake moja anafanya bondi hapa, na silicon huyo anatoa elektroni yake moja anafanya bondi hapa. Bado elektroni zake 2. Anatoa elektroni yake moja anafanya bondi hapa, na huyu anatoa elektroni yake moja anafanya bondi hapa. Kuna electron moja ya phosphorus haina pa kwenda. Na kwa sababu elektroni haina pa kwenda, tayari hapa ni complete. Electron inakuwa denoted as a free electron in the material. N-type semiconductor is going to be produced in this way. Kwa tunachokipata hapa ni N-type semiconductor. This is a type of extrinsic semiconductor. Now, in the multiple choice there, when a silicon element is doped with the phosphorus atom, it produces A, we have a P-type semiconductor. B, we have a PN junction diode, is not the answer. C, an intrinsic semiconductor is not the answer. A bipolar semiconductor is not the answer. In this case, our answer will be an N-type semiconductor. N-type semiconductor. N means negative. N-type semiconductor, negative type semiconductor. This semiconductor will be negative type because we are going to have majority carriers free electrons here. A calculated amount of impurity atoms will be added to the silicon to produce the required number of free electrons. As a result, the semiconductor material will have larger number of free electrons, and hence we call it N-type, means negative type. Our answer will be E. Roman 7. Which of the following is an example of a scalar quantity? Scalar quantity. First of all, lazima tujue scalar quantity ndio quantity gani. A scalar quantity is that a quantity having magnitude only. Is a physical quantity having magnitude only, no direction. When we say the quantity has magnitude only, for example, when you are talking about the temperature of a body, the temperature of a body is 30 degrees centigrade. Temperature is a scalar quantity because we are talking about magnitude only. Temperature got no direction. Hatuwezi kusema kwamba the temperature of a body is 30 degrees centigrade north. Hatuna kitu kama hiki. Hatuwezi kusema the temperature of a body is 30 degrees centigrade towards the right or towards the left, or the temperature is 30 degrees centigrade upward. We can't say that. Now, in the multiple choice there, part A, anasema electric current. Electric current. Current is a scalar quantity. When we say that the current is 2 ampere, the current is 2 ampere. This quantity got no direction. We have the magnitude of the current only. So this is a scalar quantity. Electric current is a scalar quantity. B, force. Force is a vector quantity because when you say the force on a body is 2 Newton, you can say force is 2 Newton towards the north, or the force is 2 Newton towards the right or towards the left. The thing has magnitude and direction. Velocity also. The velocity of a body is 2 meters per second. You can say 2 meters per second north, or 2 meters per second south, 2 meters per second towards the right or towards the left. Velocity is a vector quantity. Displacement. Displacement also is a vector quantity. When you say the displacement of a body is 5 meters, you can say the displacement is 5 meters north or 5 meters south. Displacement is a vector quantity. Acceleration also is a vector quantity. The acceleration of a body, you can say acceleration, let's say 5 meters per second square. Has direction, it can be north, can be towards the south, etc. But when we are talking about electric current, we are talking about magnitude only. And therefore, electric current there is a scalar quantity. A. The answer here is A. Okay, we continue with Roman 8. What role does the iris play in the human eye? Now, in the human eye, we can draw the human eye here. Just a simple sketch. Just a simple sketch here. The human eye. In the human eye, we have the iris here, and here we have the lens. We have the eye lens. This is the iris. The iris. The iris will control the size of the pupil. Pupil ni ile tundu ambayo linaruhusu amount ya light kuingia huko. Kwa hiyo kuna light from the outside enters the eye through the pupil. Ni tundu dogo. lakini the size of the pupil is controlled by the iris. If there is a dim light, right, the size of the pupil inakuwa kubwa kwa allow much light to enter the eye. Na kama kuna high intensity of the light, basi the pupil becomes small, ili kuruhusu mwanga mdogo kuingia katika jicho. Kwa maana hiyo, hii iris inaonekana kazi yake hapa ni ku control the size of the pupil. The size of the pupil. Let's see. To hold the lens in position is not it true. B, to prevent internal reflection is not the answer. C, to control the size of the pupil. C is the right answer here. C. To control the size of the pupil. To hold the lens in position. The lens is held in position by the suspensory ligaments ambazo zimeshikilia hapa katika ciliary muscles. Kwa hizi ndo zina hold the lens in position. Lakini the iris will control the amount of light entering the eye to protect internal reflection. Internal reflection haiwezi kuwa protected by the iris. Internal reflection inakuwa protected na vitu vingine ambavyo vipo katika jicho. Ile black pigment ambayo ipo katika jicho ndio ina kazi yake nyingine hiyo. Kwa hiyo in this case, kwa sababu we are talking about the iris, but the iris will control the size of the pupil to allow the amount of light required to pass through the lens. Okay, we go to Roman 9. Asteroids which manage to reach the Earth's surface are called. Okay. Asteroids zinakuwa ni mass of stone and rocks. We know that in the solar system we have the sun. We have planets around the sun. We have Mercury here. We have Venus. We have Earth. From Earth, this is Earth. This one is Mercury. This one is Venus. This one is Earth. We have Mars. This one is Mars. Saria Mars. And we have Jupiter. Jupiter. Now, between the orbits of Mars and Jupiter is a wide region of space. In this region, we have a collection of particles. These particles between the orbits of Mars and Jupiter, we call them asteroids. As masses of stones and rocks of different size. The largest one has a diameter more than 1 kilometer, and the smallest one has a diameter less than 1 kilometer. They move around the sun while rotating in the same way as the planets do. But sometimes asteroids zinaacha njia zao na zinaingia katika Earth's atmosphere. Asteroids ambazo zinaingia katika Earth's atmosphere vinakuwa ni vimondo, shooting star. Sometimes wanaita meteors. Hii ni asteroid ambayo imeacha njia yake na imeingia katika Earth's atmosphere. Kwa hiyo inakuwa ni kimondo, a shooting star. Sometimes wanaita meteor. Now, meteor inafanya friction between it and the atmospheric air. Friction between meteor and the atmospheric air cause it to burn. As a result, ash and dust will reach the Earth's surface. Sometimes the thing will not burn completely and manage to reach the Earth. When it reaches the Earth, its name become meteorite. Meteorite. This is an asteroid which managed to reach the Earth's surface. Kwa hiyo katika majibu yetu pale katika multiple choice anasema asteroid which managed to reach the Earth's surface are called A, star. It's not a star. B, meteors, not a meteor, because a meteor inakuwa ni a shooting star, is a small asteroid that move in the Earth's atmosphere, appearing in the night sky as a streak of light. C, we have meteorites. That's our answer. C. And the naughty constellations. Constellation is a small group of bright stars in the sky that form a definite shape when viewed from the Earth. E anasema comets. Comet is a body made of dust, gases, and the other materials that move in an orbit around the sun, in an eccentric orbit, in an elliptic orbit. So our answer here should be C, meteorites. We continue. 10, Roman 10. Okay, we have data here. In our data, what will be the resistivity of a wire 2 meters long? The length of the wire is 2 meters with the cross-section area 0.50 square millimeters. Hatuwezi kutumia ikiwa katika square millimeters because millimeter is not SI unit. We have the length in meter. This is the SI unit. Kwa hiyo lazima convert 50 millimeter square iende katika square meter. The relationship here we can say 1 millimeter is equal to a milli. Milli is 10 power minus 3. You can say is equal to 10 power minus 3 meter. This is the relationship. A milli is 10 power minus 3. But our point of interest here is to know the millimeter square. So we have to square this. You have to square this. And therefore you can say 1 millimeter square is equal to 10 power minus 6 meter square. We have 0.5 millimeter square. 0.5 millimeter square. What is this? We cross multiply here. When you cross multiply, so our cross-section area here will be 0.5. You multiply by 10 power minus 6. Now, so our cross-section area here will be 0.5. You multiply by 10 power minus 6. This is a meter square now. And a resistance of 2.2 ohms. The resistance, we have 2.2, 0 ohms. What will be the resistivity of a wire? The resistivity of a wire can be obtained from the resistivity formula. From the expression of resistivity, you can say the resistivity of a material is numerically equal to the resistance of the same material of unit cross-section area and of unit length. And therefore, we can substitute here. Okay, we can substitute in the equation. We can say the resistance is 2.2. So we write here 2.2 ohms. You multiply by the cross-section area. We have 0.5. You multiply by 10 power minus 6. The whole thing here you divide by the length of the wire. 2 meter. You have a calculator here. And here we have 2.2. You multiply by 0.5. Exponent minus 6. You have this. You divide by 2. You have 5.5 times 10 power minus 7. Ohms meter in SI unit. Now, in your multiple choice, we have 5.5 times 10 power minus 7 ohms meter. A. 5.5 times 10 power minus 7 ohms meter. A. This should be A.